Alright, so I'm going to make a little video today on how to prototype a part. We're going to use my Viper as an example. This is a 95 Dodge Viper, and before you say anything, yes, I know it's not perfect, but love it. And what we're going to make is this little guy right here, this little door pull. These crack and break often. They're like 80 bucks if you can find them. But we're going to 3D print one, and I'm going to show you how to prototype that. And all you're going to need to prototype a part, for this video at least, is a screwdriver and a set of calipers, and then some free software for prototyping. So something like Tinkercad would probably be okay. All right, so we got the part out of here, and now we need to start taking some measurements. So I'm going to take this back to my office, and I'm going to show you how to use a set of digital calipers and how to reproduce something that you can print with ease. Okay, so I'm going to go ahead and explain to you how to use a set of digital calipers. And now that we have this part out in front of us, we can see what we need to measure. Now, these are the mount holes that were on the bottom. This actually could be completely flat here. I'm not sure why there was a space, why they used it exactly like this, because when I took this off the car, there was nothing underneath of here that fit this profile. These were just kind of molded that way, and I don't know why. Could have been an afterthought, who knows. Point is, when you're prototyping a part, look out for things like that, things that you could improve on the design. Because if you look in here, you can see that this is cracked underneath from all this pressure on the screws. Where did the cracking start? Where those screws mounted. So these right here, these are pressure points. You know, if you could make this whole bottom thicker, because this can all be flat where it mounts, well, you think that's going to crack? Probably not. At least not nearly as easy. So these are things to look out for when you're prototyping. But let's go over how to use a set of digital calipers. I measure everything in the metric system. I don't do dishwashers per mile. I'm sorry if that disappoints you. So make sure that when you're using your calipers, I recommend not being on inch, being on millimeter. If you get serious into prototyping and 3D design, I think you'll find that if you adopt the metric system, you're going to have a hell of a better time. Not to mention collaborating with other people, especially overseas. They're not going to measure in dishwashers per mile. They're going to use the metric system. And I think you'll just overall find it easier. So when measuring these points, we're going to start off, and I've already pre-mic'd these up here, but we're going to verify our findings here. And we're going to look and measure the outside of this mounting spot, right? So we're going to look here, and we're going to use this edge, because this is the edge that's going to pinch this, right? We want to make sure this is as accurate as we can get it. All right, and I gave it a little bit of leniency. So we've got 65.8, but realistically, if I move it up just a little bit, we've got 66. That's a negligible difference. So we're going to just put that down and keep that there. And then I've got 46 millimeters inner diameter for the mount hole. Now, this is going to be this to this over here. Now, I can't measure that with this piece up here, because this is for things on the outside. This is for things on the inside. They're both just as accurate. They're just measuring things for a different purpose, right? So that's something to keep in mind. Some people see these on their calipers and they have no idea what these are for. So just to let you know, that's what they're used for. So now we're going to measure that. So we're going to go inside to inside here. All right, we got 46.1. I rounded that down to 46 because that's not going to hurt anything, especially since these are screw holes, to be off just a little bit. So I'm kind of rounding these up. 57.1 could realistically be 57. That's fine. So now we're going to use this side, and I'm going to show you how that works. So we're going to put these in here. Raise it up. We got 56.5, and that was 57. So they might have given it a little bit more pressure. They might have been a little bit more square. So we're going to try that again. 57.2. Okay. So that's closer to what I got originally, right? So we want to get as close to that as possible. We'll call it 57.1. That's fine. And so what we're measuring now we have the dimensions. When we go to 3D print stuff and design our 3D design, how far this is from here to here, from here to here, and from here to here. That'll let us figure out how big the holes need to be and how far apart they need to be. And then if we get stuck and we find out something didn't fit right, we can go back and double check our measurements. So that's the whole point of miking something like that out. Now I'm going to mic the rest of this object out. Things to keep in mind as you're doing this, things that you want to look at, are going to be things like this guy right here. You know, how wide is this, right? So if we come down here and we're measuring the top of this, oops, sorry. Kind of hard to do with it sitting up there on those little thin guys. All right, we've got roughly 53.5 in width, right? And then you need to do the length of the object. And these are just barely going to reach, right? So that's I'm not going to be able to do that with one hand holding my camera here, but I'll mic that out. But just to give you an idea, you want to make sure that you can get as much of this as possible. Other things that you want to get, thickness of the plastic. Now an easier way and a better way to do that, to figure out the thickness, is we measure what this bottom thickness is down here, right? So we've got this, we'd measure this point to this point between my fingers, and then we measure the inner diameter, or not the inner diameter, the inner measurement from here to here. From there, we'll be able to construct an object like a square or something like that, or a rectangle in our 3D program, taking the difference of this out, and what we're left with is the thickness of that wall. That is another way to do that. A lot of the way that I design things in 3D is actually using subtraction and a lot of addition. Basic math skills. In Rhino, it's called Boolean subtraction. You create two objects. For instance, I have a whole object here. Let's say this was just a square. And then I've got this inner part right here that I've made as like a rectangle. And I want to have that rectangle within that square so that it becomes the shape of this handle. I do a little Boolean of subtraction. It cuts that out of there, and what I'm left with is the whole part. So those are a couple of things that I tend to do. Sometimes that's faster and quicker than trying to do very specific, fine measurements. It's a little bit faster. Anyway, let's get this marked out, and then we're going to put out on the paper what we've got here, all the needed things that we're going to put into our 3D model, and then I'm going to go show you how to do some 3D modeling. All right, so I've mic'd this out for you. You can kind of get an idea of what we did. So I went ahead and did a really quick, just from the top down, right? Here's the screw holes. Here's the lip, this guy right here. And what I did is I always draw lines equal to the part that I'm trying to measure, so that I know that if I need to go back, like, what did this 10 millimeter mean? It was measuring these two pieces right here as I pinched this. Okay, what's this? Oh, that must be, I measured the width between this right here. So, mic this out so you can see from the top here we got a 10 millimeter edge. That's what we're working with. I measured the wall thickness, and I did that by going through it and measuring the thickness right here, and also this wall right here to make sure it's consistent. We got 3 millimeters, so I wrote that down. For the measurements down here, this has a slant. So if you look at the profile of this, we can see this is not perfectly up and down, right? This has got this little slant right here. Now, we could do a whole bunch of complicated math on trying to get the angle, or we could do this the easy way, which is figuring out how far out this goes, and then how far down the first edge is, and then how far down the second edge is. And then from that, we'll be able to just design that in our 3D program. So we need to get what the length is from here to here, of course, but you can see that I've already mic'd out like what the distance is for those. So when we go to put that in, we'll have what that slant is. We'll have that calculation done. Now we got these little hooks. I didn't draw it great, but you can see that there are some hooks to keep these in here. There's little clips on the side. And we've got 4 millimeter from the top of the lip down here. And then we have got 3 millimeters is how far they protrude. As long as you have mic'd out your object, at least in a primitive enough fashion like this, you should be able to go in and do some 3D design fairly easily. So let's go do that. Hey everybody, so the next thing that we're going to do is I'm just going to show you some basic sketching skills in Rhino. This is the software that I use. You can use Tinkercad or Google SketchUp or there's a bunch of different free alternatives. Realistically though, this is the one that I use because I bought a commercial license for it some time ago. and I've been using it since high school in the year 2003. This is now Rhino 7. I used Rhino 1 when it came out, and I have continued to use it. I love this tool. You can do what you wish, but we're going to start by going to new, and we are going to go to small objects, millimeters. The difference here is you have large objects, but the grid scaling is different. Since we are going to be doing more fine work, we really want to use millimeters on small objects. And so having mic'd out your object, I'm just going to show you some of the basics. We're not going to go create a whole object today because it can take hours and hours to do that, and I really don't want to waste your time with my first tutorial. I really want to make this something that's like, hey, here's how you use a set of digital calipers, here's how you mic something out, here's kind of the things to look for, here's how to do some basic shapes. And sort of the quicker ways I get to the actual object I'm trying to make. And so that first part that we're going to make today on this is it's going to be the lip. And by the lip, I mean, if we look at this object, we've got the outer ring right here that I measured. The outer lip is 10 millimeters. The inside was 40 millimeters across. And so we're just going to make the outline of that and then make it 3 millimeters thick so you can see how easy it is to do that. Because looking at something like this, you might go, I don't even know where to start. Okay, yeah, I've got this 40 millimeter measurement and this 10 millimeter and this thickness, but now what? Now what do I do? We're just going to go through that. So let's go through the motions. First things first. We are going to make some lines, and that is just to kind of sketch out a rough idea of my dimensions. You don't have to do it this way. I'm a visual person. I like to learn visually, and so when I'm doing this stuff and putting this together, sometimes I come up with quicker ways to do it. So we're going to click line up here, polyline. I always start in the center grid point, and we know that our measurement across is 40 millimeters. So we're going to type 40 and enter. We're going to click it so it's straight up and down. And go ahead and hit enter. Now we got our 40 millimeter line. The next measurement was across, and we know that that was 134 millimeters. So we're going to go end to end over here and type 134, hit enter. Then we're going to click so it's nice and straight and hit enter again. And now we've got this cross section, and that is our 134 by 40. But it's not a square object, right? It's kind of an oval. What do we do about that? Well, okay, I've got an idea. We're going to draw some circles. So we're going to go up here and go to circle. We're going to start at midpoint, come up here to the end point. And what that does is that now we know that this circle is going to make that oval edge for us 40 millimeter. But the caveat here is if we put this all the way out on the edge, now this object is a little bit longer than 134, right? That's a problem. How do we get around that? I'm going to drag this line over, and we're going to line these up so that this white dot here, which is the edge, the square edge of this circle, lines up with the end of my line. And now I'm going to copy it, and I'm going to paste it, and we're going to do that to the other side. And now we're going to check this, make sure it lines up. We look there, it's lined up. And now what? Well, we're going to copy this line. We're going to go down. And now we're going to take the guy that we drew in the first place, this 40 millimeter line, make sure it's in the center of the first circle. Line that guy up, it is. We're going to type mirror, makes things easier. Go to a midpoint. Select a nice flat plane. And there we go. Right dead smack in the middle. Okay, but now what? Now it looks like some kind of a funny car on wheels, or I'm trying to draw wheels on a car. We need to make this the oval shape for what I'm looking for. There's a very nice function in Rhino called trim. We're going to hit trim. We're going to select the cutting objects, and they are going to just be these lines right here. Nothing more, nothing less. We're going to hit enter, and now it says select objects to trim. Now we're just going to start trimming them. We don't want that. We don't want that. We don't want these inner pieces of the circle. We don't want those, and we don't want those. And just like that, we delete these lines, and now we have the outline of this shape right here in the exact dimensions that we need. You can verify this by taking your calipers, and you would go ahead and measure all the way along, remember, outside edge here on these, and you would measure this and make sure, okay, the dimensions that I'm getting on my calipers, I'm going to draw a line from midpoint to midpoint. And what you can see at the bottom of the screen here is it will tell you what that line is when you click on it. So we go here and we can see when we're drawing it, this is 95 millimeters. Oh no, I'm sorry. That was from the seaplane. 134 millimeters. So that's exactly what we would expect, right? That is what we initially got. So 134 millimeters. Sorry, I was reading the wrong thing. So that's how you're going to verify your stuff. So when you're miking things out, you want to verify when you're going through your objects as you're creating your object in 3D, that you're going back, measuring it in 3D, and then miking it out with your calipers and just saying, yeah, that's pretty close, or that's right on the money. That's perfect. Now, this has a 10 millimeter ring, so we would need to do the same thing for the ring. Now, this is an interesting object because this is, these don't protrude past this and have a larger diameter. This is 10 millimeters all the way around. So to do this, all we have to do is go 10 millimeters up from end. So we go 10, like this. And we're going to go ahead and do that down here, 10. And then I'm going to make one line from top to bottom here. And we're going to do the same thing with the circle. We're going to go midpoint all the way up. And we're going to copy and paste that guy so that the midpoint's over here. We're going to draw a line, end to end. And then we're going to go back to trim. We're going to select these guys as our cutting points. We could probably do this one line here. And we're going to get rid of all the stuff we don't want in between. Just like that. Now we have got all of the lines that we need. And if we get rid of these extra lines that we just made, we can see that now we've actually got that lip. That lip needs to be 3 millimeters. So what we're going to do is we are going to drag over all of these, and we're going to click join. And you're going to notice at the top it's going to say this many curves into closed curves. That's good. Now click off, click on, make sure that they're solid. They are. It's perfect. We're going to select both of them. We're going to go to curve and extend curve. I'm sorry, extrude curve. We want to extrude. Surface, extrude. I'm sorry, straight. It's been a long day. All right, so we know that the lip is 3 millimeters, so we're just going to type 3. Right, so 3, that's 3 millimeters. Now we're going to drag both of these, and we're going to look at that and make sure that it's shaded properly. That looks correct to me. That's what we should be seeing. Let's see if we can get away with a loft. I think we can. Yeah, it looks like we're going to be able to get away with a loft. Yep. And so lofting is just basically taking a curved edge to another curved edge and creating a surface. You're kind of patching an object together. Is there easier ways to do this? Yes. Again, I'm a visual learner. This is just kind of how I do stuff. Now we can select all of these and we can join this. And if we go to solid and we cat planar holes, we're going to add everything on the bottom, and now it is a solid surface. So now if we go back and we look at our object that we're working on, we were to turn this guy sideways, we can see that we got a 3 millimeter lip. And in the object, we've got a 3 millimeter lip. The protrusion is roughly 10 millimeters from the bottom to the top. We can double check that in here. And this part of the object is ready to print. I'm not going to go through and do all the complexities on this today because we'd be here for hours. There's just too many things to learn. I really wanted to get you guys started with how do digital calipers work. Again, this is a $10 set of calipers that I got at Walmart. Are they the best? No. Are they going to get you started? Absolutely. And Are there 3D design software suites out there that are free? Yes. Will they get you started in creating this kind of stuff? Absolutely. So let's just say that we wanted to now print this, right? We need to export this file, and we need to make it into what's called an STL. So let's do that. 3D software, I always save my file. So we're going to save this. And we're just going to go ahead and go into, we're going to go into the template files. It's fine, but we can just make a new one here just for the purposes of this demo. And we're just going to call this demo. And we're going to call this, let's call it handle ring, because this is the outer ring of it, right? And we're just going to look at that. And we're going to save that as a Rhino file because we want to be able to make changes to it. Once you make it an STL, it's kind of a pain to go back and do it. You can, but you can't. You don't want to. So we'll save that. And now we're going to do that again. We're going to copy this guy. And we're going to go export selected. We're already in our car parts. Sure, this isn't my Yelpa, but we're going to put it in here anyway, just for the purposes of the demo. And we're going to choose STL, stereolithography. That's what we're looking for. We're looking for stereolithography. So the STL file is what's going to be known as sliced when we are done. So we're going to call this the handle ring. That's fine. I know where that's at, so we're going to go there. It's going to ask you what the maximum distance are. I use this at 0.01 millimeters. I always leave this default. Always do binary. All right. So now we have it exported as an STL. Next most important thing is we need to slice it. So this is how we're going to load it to a 3D printer. Now, everybody who has a different printer is going to have a different slicer that you're going to prefer. I have a Prusa MK3S, so I use Prusa Slicer. This is the beta version because it's got the different options for slicing that I like, namely so that I can use my 0.6 nozzle a little bit easier. And now we need to load up the file. So we're going to go ahead and import that. So we're going to import STL. And here you go, handle ring right there. Ta-da! Okay. And so the things that you want to consider when you are slicing an object, when you are making something that you're prototyping, is the material. Is this going to be something you're going to drive around with for a little while? If it is, probably don't make it out of PLA. PLA is not going to hold up to heat. It's not going to hold up to the elements. It's great to get something very quickly printed off the printer and onto your car or whatever you're using. If it is going to be something that you're going to use for a while, I would recommend ASA or PETG. And the reason for those are they handle up to the elements better. They don't tend to warp as easily. PETG is tougher to print with, for sure, if you are new to 3D printing. I've oftentimes had a hard time printing PETG when I was first learning. My recommendation to that is get an enclosure for your printer if you really want to do PETG. Otherwise, sticking with something like PLA just for temporary prototyping is probably okay. For actual production prints, PETG, ASA, the other one would be nylon, is a good one. It holds up against gasoline and chemicals quite well. So if you're going to do something that's going to be in the engine bay, it's got good chemical resistance for nylon. There are some that are less caustic than others. And so plastic is going to be your biggest thing to select, right? If you make it out of the wrong material, it's going to suck. So let's start with the next thing, and that's how we want to print it on our printer. The direction you print something on a printer is going to directly affect its strength. Now, if I had scroll holes in here in the top, and I was bolting this down exactly like this face down, this would be the right way to do it, because the layers are coming from the bottom to the top, and I'll show you what I mean. If we zoom in here, we can see layer by layer how it's going back and forth and back and forth. We've got a little bit of filling material in there. Realistically, you'd probably print this without infill, but you get the idea. Now, if I wanted to print this incorrectly, I could make it face down on this face and print up. But as you can imagine, this is not going to be very strong. And the reason for that is when we slice this guy, you can see all the layers are coming through here. Well, what happens when you apply force to something in this face? Because this is going back and forth here, you're going to be prying it apart, right? Those layers are going to crack. You're going to split it. So that's something that you need to keep in mind when you're printing something. The direction that you print something is going to directly affect the strength of the print. So I think that's about all I want to cover for today on this particular tutorial. Again, I know this is already a little bit of a long tutorial, and this is some fairly basic stuff, but I wanted to take you beginning to end on how to begin prototyping parts, how to measure things, how to put them into 3D modeling software, how to export it as an STL, and how to slice it. Once you've sliced it, you can easily just slice it now, give it an export G code, put that on an SD card, and throw it on your printer, and Godspeed. But yes, there's always more to it than that, but I hope this will at least get you started. If you have any questions, ask away in the comments. I'm always happy to help. 3D printing is a passion of mine, as is 3D model design. I do a lot of functional prints. I actually got into 3D printing because I had a car that I had restored. It's an 87 Lamborghini Yelpa. There's a lot of parts I could not get for it, and I ended up making a lot of stuff. And so it was sort of a skill that I picked up forcibly. But it's been a good skill that I picked up forcibly. But I think anybody can use it. There's things that you can make around your house. There's great applications in engineering, art. If you want to get into art style, Blender is a great software that you can get for free. At least it's free right now. And you can do all kinds of artistic, beautiful stuff in there that you can print. If you want to make more realistic things, scanning is an option. You don't have to spend a ton of money on scanning. You can also do scanning with those old Xbox, what are they called? Well, yeah, they had the cameras, and you'd play, and you'd be able to detect a person in front. Well, they're very, very, very good at picking up objects and scanning them. And there is software that is open source that you can use to basically, you can go buy one of those off eBay, have your own scanner, go scan your own objects and print them. Pretty cool. So lots of different ways to prototype stuff. Again, don't have to start with an expensive set of calipers. If you're just getting into the hobby, go with some inexpensive tools. I do recommend starting with the metric system. It will make collaboration with other people and the industry much easier long-term for you than measuring dishwashers per mile. But above and beyond that, I hope you found it useful. Ask all the questions that you want. I'm happy to make more videos, and I hope you have a wonderful week.